Welcome back, everyone. Thanks for joining. And previously, I have shown you how the process works in creating an enclosure like this. So basically, just a quick overview of all the tools that are involved. Today, I'm going to show you how to use FreeCAD to create this enclosure. So essentially, basically an adapter. Ideally, what I'd like to show you is the capabilities of FreeCAD. This is going to be a warm introduction, so I will assume that you have very little experience to no experience whatsoever with FreeCAD. And I just want you to get a little familiarized with what FreeCAD actually looks like, and that is really the purpose of it. And I also want to kind of have a bit of a comparison as to, in other words, comparing how to create this object using the functionalities of FreeCAD, and then I'm going to show you how to basically copy paste Python code, and within 1 or 2 seconds your object will get created. And one more thing, I'm going to be using FreeCAD as my go-to tool for anything CAD created, basically all prototyping. And I want to standardize on FreeCAD. Not to say that I won't be exploring other tools, but this is something I want to standardize on. And it's always good to, even if you use a lot of different tools, which I like to do because I just enjoy applications. I love software. I basically download anything that I could possibly download. I love it all, the whole gamut of it. I enjoy exploring different capabilities that different applications offer, but it's important to standardize on one tool, and that is a comfort zone. So you want to reach that comfort zone where you feel like you could just about create anything and nothing is kind of brand new in terms of capabilities or that unknown factor. So if you standardize on something, you feel comfortable with it, you can pretty much then focus on the creative part of things. So without any further ado, let's dive straight into it. Again, the objective, let's create it manually, and then I'll show you how to do it by code. To download FreeCAD, simply go to the download, and depending on the environment, basically mine is the M series processors on the Mac. So you just click on Apple Silicon and it will download the application. It's a very straightforward install, so I won't go into the process of it. But essentially, there's no login, you don't need to create an account, and it's yours to use forever for free. And this is why I love FreeCAD. It's just very straightforward. By the way, if you ever do want to donate, I donated a bit just to because I love using the tool so much, and I do appreciate the good folks that spent their time and the fact that they've updated over the years and maintained it. So that's just me. Again, totally free, love it. So once you install it, we will go and basically just start it. Upon starting it, this is what you would see. In the center is obviously the main window where all the magic happens. At the top, you'll notice that you have workbenches. So we would be using the part design workbench. But at first, I want to show you what a workbench really is. Essentially, depending on which workbench you use, it provides you with a series of tools at your disposal. Kind of like a garage, depending on how you want to go about building things, you're going to use specific tools for that process. We're going to go ahead and use the part.
and you'll notice that a new series of tools are now available. They are all grayed out. That's okay because we need to first of all create our project. So let's create the first document project. We'll click on File and New, and we're going to save this as, we will give it a name, and we will call it HEpa enclosure. There we go. Next step, we want to go ahead and create the frame. To do so, we're going to go to Cube. By the way, if you don't want to, you do not need to follow me at the moment. Everything is on my GitHub page, so you'll have the full instructions, and I will have the links provided at the bottom of this episode. So we will click on Cube and notice obviously we get the cube. Now, what I want to do is I just want to rename this to outer frame. Now let's give the outer frame, you'll notice by the way that this is a tree, so kind of like a parent-child relationship. And we have the the objects, and we have the subcategories of those objects. So the outer frame, first thing we need to do is give it some sizes. Well, the size that we need. So we will go to the data window, and notice every time we click on it, we get the data window. A lot of it, what happens is in the placement. But for now, we want to give it the length, the width, the height. By the way, if you just to get you familiarized with the segments, if you don't already know, the basically the length is the x-axis segment, the width is the y-axis segment, and the height, think of it when it gets printed in a 3D printer, the height is your z-axis. So you've got your x, you've got your y, and you've got height, which is your z. So the length, we will have it at 118.5. The width is going to be 20, and the height is going to be 82.2. We now want to recenter it. So in order to recenter it, we're going to go at the top where it says fit all. Just click on that, and there we go. We have our outer frame. Let's create the inner frame. So for that, we are going to click on Cube again. Let's rename this inner frame. There we go. So you're going to notice that we have a couple of, we have another cube with some segments that appeared at the bottom left corner. Let's give this a size as well. So the inner length will be 108.88. The width will be 20. And the height will be 72.2. We do have a tiny problem here. We don't have it centered. So in order to center it, we need to position it properly. So in order to give it a proper positioning, we want to go to the position, and we want to have the X as 4.81. We're going to keep the Y as is, and we're going to put the Z at 5. And there we go. Now we have it centered. Now what we want to do is we would like to make a cut. So to make the cut, we're going to click on the outer frame and we're going to hold the command button down or the control if you're using Windows. Now you're going to go to part and you're going to go to Boolean and you're going to go to cut. See what happens now is we have a perfect cut. And if you hold the your scroll button on your mouse and click on the left key, you can now just spin it around and you could always recenter it with the fiddle. There we go. So you'll notice that we now have a object called cut. So that is the object name. What I'm going to do is I want to change the name and I'm going to just rename it frame. And here we go. And our frame contains the outer frame and the inner frame. So you can always re, recreate those. And now we're going to just remove those as well. So next step, we want to create the cylinders. So we will start with clicking on the object that is the cylinder. And you'll notice there's a cylinder that's just appeared. And we're going to call this left cylinder. So let's rename this as right cylinder. Same thing, same process, minus 90, minus 90 for the angle, so minus 90 degrees. The axis position is 1 on the X and 0 on the Z and the Y. The radius, again, same thing, 13.10. And the height remains the same as 10. And now we need to position it. So it will be on the X 128.80. And the rest will be exactly the same. So we're talking about 10 on the Y and 41.1 on the Z. So it's exactly parallel to the other one. And there we go. We now have our cylinders. Now, the next step, once we have our cylinders, is we want to fuse these to the frame. So to do so, we're going to click on the frame and then choose the cylinders using, again, if you're using a Mac, it's Command or Control on the Windows, if you're using Windows. So we'll go to Part. So we want to fuse these, Boolean and Union. And now we could see that this is the fusion. Basically, it's one whole structure now. Next thing that we want to do is we want to create the holes. So basically also known as the bores. So we're going to create the left bore. And to do the left bore, we're going to go back to cylinder. And let's rename this as left bore. There we go. Now, for the left bore, it's going to be obviously, it has to be smaller than the previous, than the main cylinder. So the radius is different. It's 10.30 for the radius. And the height remains the same. The position, by the way, the angle is going to be again the same. So we're talking about 90 degrees, minus 90 degrees angle. The axis is 100. So we need to go to the axis and make sure that it is 1. Pretty much what we've done for the regular left cylinder. And it would be the same process for the right one as well. And now we want to place it in the correct position. So the position will be minus 10.3 on the X. It's going to be 9 on the Y. And it's going to be 41.10 on the Z. And there we go. And we could see that it's perfectly fitting in. Let's do the right bore now. So just click anywhere. Our data disappears from our data window, and we'll choose cylinder again. And here we go with another cylinder. This one will be called the right bore. And there we go. The right bore, same process. We're going to use minus 90 degrees for the angle. The axis, we want 1 on the X, 0 on the Z. And we want to give it the radius, which is going to be the same thing, 10.30, or sorry, 10.3. Same thing, easier to say. And the height remains at 10. Perfect. Now we want to give it the position, so let's position it. Let's go to the position. So on the X, it's going to be 128.8. Now you can notice how it's on the other side. On the Y, it will be 9, same thing. And it will be same thing on the Z, 41.10. Let's go back to position. So the Y is 9 and 41.10. There we go. Now let's have a look and see what we have. So you could see that we have the bores inside, and this will help us get the voids that we need. So essentially, we will have the holes, and it's all going to be ready for printing. So what do we do next? We just need to make sure that we cut the bores out. And to do so, we're going to choose the frame. So that is the fusion. So click on the fusion, which is our frame, and we're going to choose the left bore. Let's go to part. Let's go to Boolean. We're going to do a cut. There we go. Now we're going to do the same with the right bore from cut. So we have the cut. Now let's choose the right bore. Let's go to Boolean, part, Boolean, and cut. And now we have the other cut. There we go. And this is our model ready for printing. So basically, if you wanted to print out, click on HEpa closure, the actual name of the file, click on File, click on Export. So we want to cut, we want the cut, export. So we want to export this as a dot. You could do it as a dot 3mf. Dot .stl is the better one to choose. So essentially, we want to go to dot .stl. So you could save it as either dot .mf, 3mf, or dot .stl. There we go. And essentially now you are ready to go ahead and print it. Ideally, I would say try dot 3mf first, as I've have most of these created as dot 3mf. So basically you could just export it as 3mf as well. Whichever works, they should both work. Ideally, MicReality Slicer software works with both of these perfectly. And that's pretty much it. This is the next thing is to set it up for print. Basically, just export it. In my case, I'm using a Creality 3D printer. And as you could see, I have it right here. And one of the things that I want to do is set it up as a mesh. And once we go ahead and click on Slice Plate, we could see that we've set it up as a mesh. So that is the support. Let me show you what this looks like. Basically, we have the inner supports that will appear. And this one here is using the HEpa PLA. And it is a .3mf. So perfectly set up. The supports are necessary, so if you are using Creality and in a slicer, do click on the support, and that way the head will properly deposit the layers. It will just essentially, you will knock these off, and there's a bit of scrubbing that you'll need to do where the cylinders are concerned, where we've added the bore holes. So you would just use a bit of a sharp, basically box cutters, and just be very careful as you use those. Now, would you like to see how it's done with Python code? Let me show you. You could go to my GitHub page. You could go to my repositories. Get the Python code. You're going to go to the, let's make this a bit bigger. You're going to go to macro, macros. I'm just going to delete these previous ones. You want to click on create. We're going to give it a name, HEpa filter 2. Enter your code and click on play. And there you go. You have your object ready to print. So basically, we'll just click on it, click on the shape, file, and export. And you can export as STL, or you can export it as 3MF. And save it, and it's done. You're ready to import it to your slicer and print it.
And that's pretty much it. I do hope that you enjoyed this session. Next session, I'm going to show you how to prototype things very quickly. In FreeCAD, we'll be using different functionalities in FreeCAD. And basically, I hope you enjoyed the journey. Stay tuned, so do subscribe. That way you're going to get the latest, be notified of the latest episodes that are upcoming. Thank you for watching, and you can catch me next time. Take care. Bye for now.